Hi everyone! At this point, you should have added those 5 new definitions to your notes. You also should have played the quizzes, and if you had trouble with it, either replayed it until it was making a little bit more sense, or watching that other video. It was optional, but it does do a good job of talking about interior versus exterior. So being inside of the 2 lines, like in this situation, 3, 4, 5, and 6 would be interior, 1, 2, 7, and 8 would be exterior. Or in this case, since our transversal is more horizontal, then we've got interior will be inside of the lines here and outside A, B, F, and H. And then also the alternate versus same side. So alternate on either side of the transversal, so left versus right would be alternate here, where here it's like above and below are alternate, or they could be all on the same side would be same side, of course, or on the right, all above, below. So doing that first because we are just adding to that information. I also want to note that the new angle pairs that we've got all relate one cross section to another cross section. So angles that we've done in the past chapter, we were relating things that were right next to each other. So maybe 7 and 8, they're a linear pair, they're adjacent to each other. We had 5 and 8 that are vertical, and even though they're across from each other, they're still in the same little cross section, where the 4 new angle pairs that we've got are relating an angle here to an angle in another cross section. Okay, so after we know what they're called, those 4 angle pair relationships, that is foundational. It's really important for this chapter, but we can't really do much with it because, 6 and 4, they might be same side interior, but I can't solve for an angle using that. They don't have a special measure or way that they relate to each other, except when we have a special case where the 2 lines are parallel to each other. So what we're going to do in this section is go on to say, okay, if I have parallel lines cut by a transversal, I'm going to have special relationships between these 4 new angle pairs. So our supplementary, our same side interior angles, they actually end up being supplementary to each other, so they each have a special relationship that they'll have. So for each one of these, and we've got 3 theorems and a postulate, each one of them is going to start the same way. So I would write this in your notes that each one of them starts out, if 2 parallel lines are cut by a transversal, so that's what's happening. We've got these arrows in the picture that tell us that the lines are parallel to each other. So anytime we see either one arrow or do these in, if they both have 2 arrows, it's kind of like segments where they could have 1 dash to pair them with each other, or 2 dashes are all the same length. Same thing here, they're parallel. They've got the same number of arrows on them. So if we've got 2 parallel lines cut by a transversal, each one of our new angle pairs will relate in a specific way. So we've got then corresponding angles are congruent, and we can see if I'm choosing corresponding angles, both the bottom left, they look like they would be about the same measure, and they sure are. So same situation, if I've got parallel lines cut by a transversal, then our alternate interior angles end up being also congruent. Same situation again, parallel lines cut by a transversal, alternate exterior angles end up being also congruent, which you might be thinking at this point, like, how are they all congruent? I'll show you in a minute. And then the last one is the one that I gave away. Parallel lines cut by a transversal, our same side interior will be supplementary, which definitely pause the video, start that part over if you need to, write down that this is all going to be true. This is what we're using in this section. That if we've got this situation, the 2 parallel lines cut by a transversal, corresponding will be congruent, alternate interior will be congruent, alternate exterior will be congruent, and same side interior will be supplementary. So for each one of these, we have either a theorem or we just have one postulate. So the first 3 are all theorems, and they are named really appropriately for us, kind of like the vertical angles theorem told us if we have vertical angles, then they're congruent to each other. Each one of these are named by what they are called. So the corresponding angles theorem is what we call this statement that says if we have 2 parallel lines cut by a transversal, then corresponding angles have to be congruent. Same thing for alternate interior. We have the alternate interior angles theorem, the alternate exterior angles theorem, and then the same side interior angles postulate. So same side interior is the only one that is a postulate, and it's the only one that's supplementary. So it's different on both accounts, which I think makes it a little bit easier to remember that it is supplementary and a postulate. Now the difference here between the vertical angles theorem and this guy is that vertical angles theorem said if they're vertical angles, they're congruent. This is not saying that if they're corresponding angles, they have to be congruent. I have to have this situation where the lines are parallel, and then I know that the corresponding angles, alternate interior, alternate exterior, are congruent, and the same side interior are supplementary. So we do end up with a lot of them being congruent to each other, so let's just explore what that looks like in our parallel lines and transversal. That means we've got a lot of angles that are the same, but it kind of makes some sense. We've got just starting out with one angle. If this is 130 degrees, that means the angle that is vertical to it would also be 130 degrees. We just learned that corresponding angles would have to be congruent, so I could go from that 130 to here. I could also go from that original angle to an alternate exterior angle that we also know is congruent, which we knew the vertical angles would be congruent anyway. Okay. I could also start with one of these angles and give the linear pair angle to it. The supplementary angle would have to be 50 degrees. I've got to add up to be 180. And then I could go vertical angles here. Maybe from there to use corresponding or alternate interior. Okay, so we can see when it's all written out, we've got all of our angle measures. We really just have two angle measures. They get repeated several times, 4 times. And we know by our corresponding angles being congruent that both of those cross sections are going to look exactly the same. So that's how we have so many being congruent. But notice our same side interior are supplementary to each other. It makes sense because if our alternate interior are congruent and they were a linear pair, that means that they would have the same side interior would have to be supplementary as well. Okay, so let's just look at a few examples, and then you've got some delta math to practice. This really just comes down to knowing how the angle pairs relate to each other. So if you need to keep notes in front of you for today, that's fine. Just working towards that. The first times that we were using vertical angles, it took some practice to get in the habit of every time I see vertical angles, they're congruent. So same situation with these. So starting with A, I would have, okay, I only have these two angles, my 120 and X, which I could find some other things. I could move my 120. I know that that's congruent to it because they're vertical. And so I could move it around. But the first thing that I would try is seeing if I can relate X and 120 directly. And they are alternate exterior angles. So I'd be digging back into my brain or my notes, say, okay, oh, I know if I've got parallel lines, then my alternate exterior are congruent to each other. So X would equal 120. If I was justifying why I knew that, then I would use one of those theorems or postulates. So for this one, I know X equals 120 by the alternate exterior angles theorem. For B, same thing. I want to see if I can relate that 80 and 2X directly. They are same side interior angles. So now that we've seen our theorems in the one postulate, we know that 80 and 2x have to be supplementary to each other. So I want my equation to reflect that. I've got the angles being supplementary, and then solving for x. My reason or my justification would be the same side interior angles postulate. Okay, last one that I want to look at, and of course, with things like A and B, you could get a more complicated equation where, you know, you've got 3x minus 17 and 2x plus 5, and so you're setting up an equation where they equal each other and then solving for x. But I'm confident that once we have those relationships down, we're all very good with the solving piece of things. It's the new theorems and postulate that we're working on. So last one is C, And if we're trying to think of how to relate them directly, we should be a little stuck because this is not one of our new angle pair relationships. These are both exterior, but they're not alternate, and there's not a same side exterior. That's not one of our angle pairs. So if I'm working something like this and they don't relate to each other right off the bat, I want to move them or find other angles that are congruent to them that allows me to use a postulate or theorem that I know. So if I know, okay, my 54 degrees, it is exterior, so I know that alternate exterior to it would be up here, would have to be congruent to it. I could use those angle pair relationships, and now I've got them right next to each other. They're a linear pair. I know that they do have to be supplementary. Or I could do more digging than that. We could move my 54 degrees has to be congruent to its vertical angle, and the x plus 2 has to be congruent to its vertical angle. So then they would end up being same side interior. Again, they've got to be supplementary to each other. Sometimes it takes a little bit more than just setting up your equation right away, where for this one we had to do a little bit of thinking to decide that we were going to set this up as being supplementary. But that is pretty much the gist. So working on setting up your equations, deciding what kind of angles you've got, setting up the equation, and then solving. If you have to move an angle before you set up an equation, then do that first. Move it where you know you've got another angle that's congruent using vertical angles or same side interior, or sorry, not same side, don't do same side interior. Alternate interior, alternate exterior, or corresponding, using those to move it somewhere where it's congruent, and then solving. All right, well, enjoy your snow day. Goodbye.